In this video, we explore one of Python's most important ideas, the difference between a name and the object it points to. Understanding this will save you from some very surprising bugs. Python variables are not boxes that hold values. They are labels that point to objects living in memory. When you assign one variable to another, you copy the label, not the box. Think of the list as a cardboard box. Writing b equals a sticks a second label onto that same box. There is still only one box and only one list. Here is the program we will trace. 4 short lines, but they reveal exactly how Python handles names, objects, and mutation. Line 1. Python creates a new list object containing 1 and 2 somewhere in memory. The name A is then bound to that object. Nothing is stored inside A is just an arrow pointing at the list. Line 2. B equals A. Python does not create a second list, it simply makes B point to the exact same object that A already points to. We now have 2 names, 1 list. Line 3. We call append on B adding 3 to the list. Because B points to the same object as A, the list that both names point to is now 1, 2, 3. The object itself changed. This is called mutation. Line 4. We print A. Python follows A's reference to the list and prints its current contents. Even though we never wrote a dot append, A shows the new value, because A and B point to the same object. Running the program prints 1, 2, 3 inside square brackets. We only called append on B, but A shows the change. That is reference sharing in action. The golden rule: assignment shares references, it does not clone objects. Whenever you mutate a mutable object like a list, every name pointing to it will see the change. Keep this in mind, and Python's behavior will always make sense.